Hello, everybody. In this video, I'm going to go through lesson 3.1, Intro to Radicals. So first things first, we kind of need to talk about what is a radical. So some basic vocabulary. This is a radical symbol. So this is what we call a radical, I'm going to call it symbol. And your radical symbol always has somebody in the house. We are taking a root of some radicand. So that is really the number you are taking root of. And normally we're taking a square root, right? And that's kind of like there's an invisible 2 here. But we can have different numbers in what we call, and what color do I want to use? What we call our index. So this could be a different number. Looking at some specific examples, we are very well aware of just a plain old, the square root of 4. Like there's an invisible 2 there. So this is a square root. And it can be, again, any number underneath that radical. If you have a 3 in your index, we are now finding what is known as the cube root. If you have a 4 in the index, that would be a 4th root. And then that kind of just continues on. Any number that is in your index, we call that, then you're taking the nth root. So you could take more than just a square root. And what really is that then? If you're taking, just a square root, what are you doing? And I like to look at an example for this. We can always take a number like 5 and we can square it. And what that really means is that we are going to take that base of 5, right? And we're going to multiply it 2 times, right? What the exponent of 2 tells us. We get 25. So 5 squared is 25. If we take the square root of 25, remember there's like an invisible 2 there. We take the square root of 25, we're really taking the square root of that 5 squared. And the square and the square root are opposites of each other. So you know how addition and subtraction undo each other? The square and the square root undo each other. So if I have 5 squared and I take the square root of that, I am figuring out, okay, what is the base number being squared? And the base number being squared of 25 is just 5. Now here's the deal. 5 is actually known as your principal root because it is a positive root. But we also have another root. -5 is another root of 25. The square root of 25 also equals -5 because if you multiply -5 times itself, you get a positive number. So -5 is what we call the negative root of that square root of 25. I'm just trying to move that over a little bit. So an important word that we're going to hear a lot is a perfect square. And a perfect square is a whole number usually. And I'm going to change it. Just write a number that has been multiplied by itself. So we looked at 25 before. 25 is a perfect square. 2 times 2 is 4. So that gives us a perfect square of 4. Because we took that same number of 2, we multiplied it twice. If we were to find an area model, this 2 by 2 box is a square. 2 units by 2 units. And so that's kind of where the terminology comes from. Let's list out, we need to know our perfect squares and square roots. So we're going to make ourselves a little cheat sheet here. Perfect squares and square roots. So starting off, 1 squared, and 1 squared, remember this is 1 times 1, that's just 1. So if I take the square root of 1, that's really just 1, right? And I'm just going to write the principal roots here. I'm going to write the positive roots. And we're going to write about negative roots when we get into a later unit. All right. Next, 2 squared. That's 2 times 2, which is 4. And the square root of 4 then is 2. 3 squared. That's 3 times 3, or 9. And the square root of 9 is 3. So that's kind of the basic pattern here. I'm going to start writing a little bit less now. So 4 squared, that's 4 times 4, which is 16. And the square root of 16 is 4. 5 squared, we saw earlier, is 25. And the square root of 25 is 5. 6 squared is 6 times 6, or 36. So if I take the square root of 36, that would be just 6. 7 squared is 7 times 7, or 49. The square root of 49 is 7. So I hope you're noticing a pattern here. Whatever number has been squared, to create that perfect square, that is then the square root. All right, 7 squared. Let's do 8 squared over here. That's 8 times 8, or 64. The square root then of 64 is just the square root of 8 squared, or 8. 9 squared is 9 times 9, or 81. So the square root then of 81 is 9. Oops. 10 squared is 10 times 10, or 100. So if I find the square root of 100, that is 10. 2 more I want to write down. 11 squared is 11 times 11, or 121. The square root then of 121 is 11. And 12 squared, that is 12 times 12, or 144. And the square root of 144 is 12. So these are our perfect squares and square roots. And I want you to identify here that every number that has been squared, well, starting at the top, 1, 4, 9, 16, 25, 36, right? And I could honestly just box them like this. Those are the perfect squares. These are all of our perfect squares. All right, now I want to talk about our basic cubes and cube roots to kind of finish up this video. So basic cubes and like that. Cube roots. So remember, we can take a square root, we can take a cube root, fourth root, fifth root. Let's talk kind of about what that looks like. So 1 cubed and 1 cubed, that means we're going to multiply that base of 1 3 times. 1 times 1 times 1, which gives us just 1. So if I take the cubed root of 1, that is just 1. Now 2 cubed is where it gets a little bit more interesting. That is like taking 2 times 2 times 2, which 2 times 2, that is 4, times 2 gives us 8. If I take the cube root of 8, then that's really like taking the cube root of that 2 cubed. And really these cancel each other. They undo each other. They cancel each other out. And our cubed root of 8, the cubed root of 2 cubed, then, oops, is just 2. And there's no positive or negative roots here. Because if I multiply -1 times -1 times -1, a negative times a negative times a negative is going to be negative. So no principal roots and negative roots here. All right, 3 cubed, that's like taking 3 times 3 times 3, and 3 times 3 is 9, times 3 gives us 27. If I find the cubed root then of 27, I'm finding that cubed root of 3 cubed. So the 3 cubed and the cubed root, those cubes undo each other, and that cubed root is just 3. 4 cubed is 4 times 4 times 4, which is 64. So 64 is a number that is both a square root and a cubed root. Pretty interesting, along with 1. But 1, boring. So the cubed root then of 64 is the cubed root of 4 cubed, or 4. So the cubed root of 64 is 4. 5 cubed, that's like taking 5 times 5 times 5, and 5 times 5 is 25, times 5 gives us 125. So if I find the cube root of 125, that's like the cubed root of 5 cubed. So the cubed root of 125 is just 5. And then the last one I really want us to pay attention to, we could do 6, 7, 8, and 9, and you can play around with those yourself. Type 6 times 6 times 6, 7 times 7 times 7, see what you get. 10 cubed, however, that is 10 times 10 times 10. 10 times 10 is 100, times 10 again gives us 1,000. So the cubed root of 1,000 is 10. Please let me know what questions you have on this lesson, and I look forward to seeing you in class.